podcast, we're going to learn what the steps for drawing alkanes are. And if you can get good at drawing alkanes, you can draw any other type of organic molecule. So make sure that you're referencing this if you're starting to struggle, because the steps are essentially the same. It's only the functional groups that change. All right, to draw an alkane, you just need 3 simple steps. You're going to start with the longest chain of carbons. So I always like to start carbon, 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 and I put my bond lines between them. Then you're going to add hydrogens until each carbon has 4 bonds. We're completing the octet. And convert to a condensed structural formula. So for this first problem, I am going to do steps 1, 2, and 3. And then on the next couple pages, I am going to go show you a little trick to go straight from step number 2 and be done at step number 2 with a condensed structural formula. So there's no conversion required, which will be helpful if you have a timed exam. All right, so pentane, pent tells me that I have 5 carbons, and ane tells me they're all single bonds. It's an alkane. So let's start with the longest chain. 1, 2, 3, 4, 5. I'm going to draw a little bond line there. See what I do with these soon. Okay, so that takes care of my 5 carbons. There's no branches on here, at least the name doesn't tell me there's any branches. So now I'm just going to worry about completing my octets using hydrogens. So this carbon has 1 bond, so it's going to need 3 hydrogens. 2, 4, 6, 8. It's an octet. We're good. And we're going to do that all the way through. This carbon has 2, 4 valence electrons already because it's sharing those with 2 other carbons. So I only need 2 hydrogens to complete my octet. 2, 4, 6, 8, done. Same thing with this carbon. It already has 2 bonds, so it only needs 2 hydrogens to complete an octet. Okay. My 4th carbon, same thing as well. On my 5th carbon, we only have 1 shared pair or 2 valence electrons, so I'm going to need to add 6 more shared pairs, which is going to be 3 hydrogens. Now, this is the complete structural formula. I need to get this to my condensed structural formula. So what I'm going to do now as a separate step is I'm going to draw my boxes and I'm going to start writing. This is CH3, CH2, CH2, CH2. Boy, that's repetitive. CH3. And that would be your condensed structural formula for pentane. Remember that once we get a little bit better at this, you can condense this down, but I don't recommend doing it at first because it can be challenging sometimes for students to count all 3 of those. Oftentimes this gets confused for propane, a 3-carbon chain. So be careful with that. So this alkane has a branch on it, has a methyl branch. Okay, that's a single carbon branch on the 2nd position of butane, which is a 4-carbon parent chain with all single bonds. So I'm going to start with the longest chain. I'm going to start with that 4-carbon longest chain. 1, 2, 3, 4. I'm going to draw my little bond lines. I'm going to show you my trick on what we do with those. So that takes care of butane. I'm going to have to add hydrogens, but I'm not quite ready yet. I want to put that branch in the right position so I don't accidentally add too little or too many hydrogens, because that is a mistake that a lot of first-time students will make. So the methyl group, the single carbon, this is a methyl group, is coming off of the 2nd position. So I'm just going to number these real quick. 2, 3, 4. It doesn't matter if I number left to right, right to left. It means the same thing because you can rotate this in space. So the methyl group is coming off of my 2nd carbon. Okay, so I'm going to leave it just like that for now. All right, so that is my my parent chain. Okay, it's not completed with octets, doesn't have hydrogens, but this takes care of every branch. Now I need to go back through and I need to add these hydrogens in to make my octets. So on this first carbon, I see that it has a single bond to carbon. That takes care of 2 valence electrons. I need 6 more. I'm going to need 3 hydrogens on that carbon in order to complete my octet. So this would be CH3. So I'm going to take my bond line knowing that, and I'm going to add my 3 hydrogens there. So in my head, I'm thinking this needs 1, 2, 3 bonds coming off of it. Okay? So I want you to kind of disregard those bond lines. I can't erase them or you will have never seen them. It's a flaw in the program. Okay, so looking at carbon number 2. Carbon number 2 has a bond to this carbon, and to this carbon. So it has 6 total electrons. It only needs 2 more. So it's going to find this and bonding to 1 additional hydrogen. So think of that 1 hydrogen is coming off of here. I'm going to put it right here. I'm going to change that bond line into a hydrogen. Okay, and it only needs 1 because it already has 3 bonds. My third carbon is bonded to carbon 2 and carbon 4. So it has a spot for 2 hydrogens to bond, 1 above and 1 below. So I'm going to turn this bond line into a hydrogen, and I'm going to add a 2 afterwards so that we can see it's a carbon with 2 hydrogens. Finally, carbon number 4 is only bonded to another carbon. It's going to need 3 additional hydrogens for 8 total electrons. So the ends are always CH3 unless there's some branch on there. All right, to clean this up, 2-methylbutane would be CH3, CH with a methyl group coming off, CH2, CH3. The best way to get good at this is to practice and check your answers with the key. All right, so let's use that same trick from last time where we're not drawing the complete structural formula, but we're kind of skipping to the condensed with our structure so we can get good at that. This structure that we are trying to draw is 2,3-dichlorohexane. So let's go to our longest chain first and we'll work our way back to the groups. Hex tells us there are 6 carbons. Ane tells us it's all single bonds. There's no double bonds to worry about. So let's start with that. 1, 2, 3, 4, 5, 6. I'm going to draw little bond lines because I'm going to turn those into hydrogens. So crafty. And I'm told that we have di means 2 chlorines coming off of this hexane, and they're coming off in positions 2 and 3. Okay, so I'm going to number down here, and I know that's kind of far away, but I don't want it to distract from the structure. I've arbitrarily chosen to count left to right. You could certainly count the other way because it means the same thing. So I have a chlorine coming off of carbon 2, so I should have a Cl here, and I have one coming off of carbon 3, Cl there. That is the entire structure. All I need to do now is figure out how many hydrogens every carbon has to complete their octet. So this first carbon has 1 bond, so it will need 3 hydrogens coming off of it. This second carbon has a bond to a carbon, a chlorine, and another carbon. It only needs 1 additional hydrogen. So I'm not going to put any subscript after the H. My third carbon, same situation. It's bonded to 1, 2 carbons, and a single chlorine. So we just need a single hydrogen to complete the octet. Carbon 4 is bonded to both carbon 3 and carbon 5. So that's only 2 bonds. So I'm going to need 2 hydrogens now to complete the octet. Carbon 5 is bonded to carbons 4 and 6. That's 2 bonds. It will need 2 hydrogens to complete the octet. And you may be starting to pick up on this pattern, but there is no branch on my final carbon. It is only bonded to carbon 5, so it needs 3 hydrogens to complete an octet.